Hello everyone, welcome back to another new video. We have a important numerical on the slope deflection method. Okay, so in this question we will solve in slope deflection method in three different steps. Okay, so first step will be our calculation of fixed moment, and second step will be slope deflection equation, and in the third step we're gonna solve all these equations by the equilibrium condition. So first move to the solution. Okay, so we have a given beam, you can see. Okay, in this beam we have three different support: at B fixed support, at D hinge roller support, at C roller support, and the value of EI is different for all the span. For B to D 3 EI, for C to D 2.5 EI, and two load 50 and 40 kN load is acting, and for C to A 25 kN load acting over here. Okay, and in the question analyze the given beam by the slope deflection method. Draw BMD. We have to also draw the BMD by the considering external load and rotation of a support B by 1 by 10 degree clockwise. So rotation at B is given. It means if we have rotation, then we need to take theta, and we have deflection, then we need to take delta del. Okay, so this is the clockwise, but this is also in degree, so we need to convert this into radian. So it be multiplied by 5 by 180, so this will be in radian. Okay, and support C settle down. Okay, so support C settle down, it means we have to take the value of delta. So delta C equal to 4 mm, this is down. Okay, so now you can see also we have the value of EI equals to 8000 given. Okay, so the value of EI equals to 8000 kilometer meter square. So this is also given in the question. Now as I said, we are going to solve any problems related to slope deflection in three different steps. Okay, so first step is calculation of fixed moment. So let's see here. Okay, so we are on the first step, calculation of fixed moment. Okay, so for the fixed moment we just need to apply the formula, nothing else. So from here you see for fixed moment A to C, here this is from left to right A to C. So load is applied at A, so but at between A and C there is no any forces, no any load is applied. So A to C moment will be fixed moment will be 0, and for right to left C to A will be this 25 into 3, 25 into 3. But you can see this is anti-clockwise. Okay, so the anti-clockwise actually negative, but we need to take the balancing moment. That's why negative, in the place of negative we take the balancing moment, that is the opposite one. So negative anti-clockwise, their negative is clockwise, and it should be taken positive. So positive 75 km. Now C to D, you can see here for the C to D span we have two loads are applied. So not to worry, we need to apply the point load formula for first load, and we need to add this value. So for the 50 km we need to add minus WAB square by L square, this one. So we calculated this value, and again we have also 40 km load. So for this C to D we have minus WAB square by L square. So we need to take W1 50 and W2 40, and all the remaining value of A will be 2, value of B will be 4 for this load. You can see here, if we consider this 50 km, then value of A will be 2 and value of B will be total 4. So you can see here this is 2 and this is 4. Similarly, if we consider this load, then the value of A will be 4 and B will be 2. So only this much difference, 4 and 2, and finally we get 62.22 km meter. Okay, similarly for right to left D to C we need to take the positive value, so this will be 57.78. Now for D to B, you can see here D to B and B to D, this is the UDL of 10 km. So you can apply directive formula WL square by 12. Okay, so the value of W is 10, L is 6 by 12, and from D to B, this is the left to right, so negative, so minus 30. And for right to left, we need to just change the sign, that is minus 2 plus 30 kilometer. So we completed the first step. Okay, and now before moving to the second step, I need to give you some important information. Okay, so our 15 days crash course will be going to start very soon. Okay, in this crash course we will mainly focus on the past questions. Okay, world is gold, and we will gonna do some basic concept relating each and every chapters. Okay, and with that all the concept we're gonna solve all the past numericals. Okay, so you can join the group. Okay, and you can also contact in the given below number WhatsApp. Okay, you can contact us, and from there you can get all the PDF, important video link, and all the past solutions in free. Okay, so you can join our group as well, WhatsApp group and LinkedIn. Okay, this will be very beneficial for you. Thank you. So now next move to the solution. Okay, so in second step, our step number second is slope deflection equation. Okay, so in slope deflection equation you can see we have to take different span. Okay, the different intermediate span. So first take the span C to D. Okay, so for C to D you can see here at the point C this is settled down by 4 mm, so we need to take this down, and this is D. So original position is our this one. Okay, and after deflection this C goes over here, C dash. Okay, so we have to stay at the right side, always stay at the right side and look new position at left portion. Okay, so we are staying right side, so at D and looking at C dash. Okay, so it means this is down, so we need to take the this delta as a negative. If looking at down, so negative value delta. Looking up, so delta will be positive. So we are looking over here downward, that's why we need to take delta equal to minus 4 mm. Okay, just remember this thing. Now as we know, the slope deflection equation is this one. Okay, this is only one equation, so you need to remember this. Okay, and you can apply all the spans, only this formula will be applied over here. So the value of MCD we have already calculated, minus 60, and 2 EI. In the place of EI for CD span we have 2.5 EI in the equation. Okay, so we will take 2.5 EI, 2 theta C plus theta D minus 3 delta. As I said to you, this is minus 4, so we need to take convert this into meter, it will be minus 0.004 meter. And finally we get the value of MCD, this one. Okay, so this is our equation number first. Okay, so this is our equation number first. Similarly we have calculated for the CD, now we need to calculate for DC. Okay, so there will be no change in the delta, so delta will be same, but change in the this moment DC, and all the value we need to put, and finally we get the second equations, this one. And similarly for the DB span, okay, in the figure you can see we have calculated for the C to D and D to C. Now we need to calculate for D to B and B to D. Okay, so for D to B we need to apply the slope equation, which is this one. Okay, and value of this one is given minus 30, and EI is 8,000, and at the place of delta there is no settled up, settled down at this portion, so the value of delta is 0. So this will be our third equation. Similarly for the B to D there will be no deflection, so delta will be 0. Okay, and at the place of theta B is rotation over here, so we need to put the value of theta B, that is 0.00174, and we get this equations. This is equation number 4. So okay, so these equations. Now in third step we need to apply the equilibrium conditions. So For the equilibrium condition, you can see here we have two different points. Okay, intermediate point you can see here for point C, for support C and C D. So support C we need to take equilibrium and apply Ca plus C D equals to 0 for this one, and similarly for D we need to apply DC plus DB equals to 0. So this will be our equilibrium condition, and from here we get all the moment value. Okay, so as I said, for the equilibrium condition for joint C, we need to take MCA plus MCD, left plus right, and then we get this equation 5. And similarly for joint D, we need to take MDC plus MDB, and we have already calculated the value of the MDC and MDB in above equations. Above 4 equations, we need to put those all the values in these uh, equations, and we get this much equation, which is 6 number equation. Okay, now we need to solve these two equations. After solving these two, we get the value of theta is minus 1.15 into 10 to the power minus 3 radian, theta d minus 1.614 into 10 to the power minus 3 radian, this much value. Now we just need to put these all the values in the slope deflection equations. Okay, only this much. So from there we need to calculate, put all the value, and we need to calculate, and we get this value. For CD got this, for DC this one, for DB this value, for this value we get all the values. Now for the moment distribution table, not to worry, we need to just put all the values, and we have to always take the sign convention minus plus. If you are looking from left to right and the value is negative, then this will be above than this beam, positional beam. Okay, and if we are looking from left to right and the value is positive, then this will be below than this is our uh, level of beam. Okay, and positive value goes down, negative value goes up. Similarly from right to left, if we look, then the positive value will be upward, uh, above than this beam, and if we have negative value, then we need to take the below than this beam. So look here, for D to C, for C to D, we have already calculated. You can see here, for C to D, our value is minus 75. So for C to D, we are looking from C to D, it means left to right. So left to right, you can see here. If we are see left to right, then the value of negative will be upward, above than this beam. That's why we need to take the above. And for D to C we have 41. For D to C means right to left. So right to left positive value will be upward. So this is also upward. And similarly for D to B is same, 44. Okay, 41. And B to D means right to left. It means we have to take positive value upward. So B to D is 44. This is positive value. So this way. And now we need to join this all the points like this. Okay, and as we know, whenever we have the UDL, then the maximum value will be for the UDL, maximum value will be WL squared by 8. So this value will be 45 over here. And for the point load, the maximum value will be PAB by L. Okay, so this will be this for the first point for 50, and apply this same formula, and second point will be this. Now we have calculated this much, okay, in first step, and we have also uh, pointed this one. Okay, now this value, maximum value. So you can see here the upper parts of this all the previous values, like this one will be plus, this one will be plus, and below than this portion will be negative, negative and negative. Okay, in this way we can make the bending moment diagram very easily. Okay, and now for the free end, you can see here uh, we have given frame for the C to D. Okay, and taking moment at D, summation moment of D taking clockwise positive, and this for the RC total distance is 8. So RC into 6, so RC into 6, and for this 50, this is anti-clockwise, so take negative value. This is 4 meter distance, and for this 40 this distance is 2 meters, so 2 meter, and from here we get the value of RC is 446.6. Similarly, summation Fy equal to 0, then RC plus RD equals to these two forces are downward, okay, and these two are the upward. So RC plus RD is equal to 50 plus 40, and from here RD is 43.34, and moment at 50 we got this value, okay, and for 40 we need to multiply this with the distance, so we got this value. Okay, so I hope you understand this. Thank you very much. Thanks for watching. Please do like, share and subscribe the channel.